Hello. Right, yes, it's been ages, but it takes a long time to build these things. So this is my latest iteration of the Scalar Harmonic Resonator, as I call it. It's kind of adapted into different things and different modes of excitation, and I just thought I would share this one with you. This is my introduction to heavy-duty electronics. I had to use ChatGPT as my lab assistant, but for a change, everything it said on how to build this, when I said what I wanted, it all worked. It's incredible. So there are about 300 connection of wires underneath there. It's a mess under that spaghetti junction, but on top it looks fine and it works, so all good. This is the coil set here. I've got it's a nested sphere set, 3:2 ratio, of course, for a musical perfect fifth. And I'll just slot this in here. Okay, and all four hemispheres are separated inside, and they have these return and entry feeds for so that each one can be pulsed separately, but still receive high voltage from these power supplies here to create a spherical capacitor. So it'll be positive on the outside to the whole sphere of the outside, and the inside would be negative. The power supply, it's just general stuff, you know. It looks really complicated, but it's actually quite simple. I needed 4 paths all the same, but they all needed to be separated out. So the easiest way to do it was to use an Arduino Nano and a separate board in there. I've got connections here that I can use to attach the signal generator for sweeping defined frequencies. But once that frequency was locked, which is the natural resonant frequency of these two coils together, I've got a sniffer probe here going to the spectrum analyzer. The screen is, it needs to go back under warranty, but I've been needing to use it a lot recently. So anyway, so there are 4 lanes all feeding the 4 different hemispheres. It's a timed circuit. So if I show you this, it explains exactly what it is. So I'll just set it down here. There's the frequency that I find on the spectrum analyzer for the system, or the F0 as I'm calling it here. I burst that inside a pulsed window, and that window, that gated period, matches the end of the wave front, so that it doesn't leave it ringing. It cuts it off neatly at the end, and then the window is pulsed in. It's pulsed with modulation, but it's fully under control. So you can put in at 200 hertz, say. You can put in whatever you want, but you're just trying to match up what the frequency is inside it, the resonant frequency, to the pulse length, and then the window goes across here. What happens is that would be the top hemisphere of the outer coil, then that's the top hemisphere of the inside coil, then that's the bottom hemisphere of the outer coil, and the bottom hemisphere of the inner coil. So the phase it's not a phase. It's just how I split it up using the logics to actually get it to work. So that's basically here how it looks. So you've got the it basically tells you you've got a sequence burst of a system resonant frequency. The burst contained inside a defined gate period. The gated period is repeated across a defined window, which is split into 4 feeds as phases, but that's how I split them in the logics. And but the beauty of this is that all the sequencing parameters are adjustable via the Arduino. So then that's basically why I put in this encoder, rotary encoder, and the little OLED screen, so that I can change different parameters that I can put up on the screen in live just to get it to see how it all works. So this is the logic side, the 4 lanes coming out, the 4 lanes go to each hemisphere. Then the idea basically is to create a DC static electrostatic capacitor. So you've got positive on the outside, negative on the inside, and then that produces quite a strong displacement current here in the cavity between the 2 spheres. So in order to excite, basically, I call it the substrate. You can call it quantum foam, you can call it whatever you want, but whatever we exist in is in that cavity. And once it is excited via the field gradient, the electric field gradient, it will actually produce a displacement current between it. And that's the only place a displacement current exists in a dielectric. So I'm assuming that the displacement current is what is able to move the substrate field once it's excited. And if it's time pulsed specifically, then it will move it, but it's still symmetrical at the moment, right? So you're still doing a pulse to here, pulse in, under, and so the whole thing is a sequence that basically self-cancels at the end of the day. So in order to, the spherical geometry should though actually squeeze it in the center so that it becomes more of an hourglass, where it comes out at the apexes and it kind of spreads out at the equator. So what I'm assuming is that when that field inside is excited by the capacitance and by the triggering, then it needs to have a net vector to actually move. So on this one, there's another feed coming here, which is also, but that's pulsed and timed to match the timing of the sequence of when the top hemisphere is hit, so that can actually come in and raise the DC bias of that hemisphere. So there is an upward trend. But when you consider it's a gentle, it's like a parametric excitation. It's like pushing a child on a swing. The swing comes up here and it just needs a little tap just to push it, and then the amplitude will increase naturally, but you've got to do it at the right place and at the right but let's put it this way, if it comes up here and you hit it with a hammer right at that point, it just makes it unstable. But if it comes up here and you just push it at the right point, it doesn't have to be a hard hit. It can be very gentle, but it's cumulative. And that's what I'm trying to do with the bursts, is to join in with the resonance system frequency to get a general excitation in it, and then a net vertical gradient to form an upward movement of the substrate field. So this is all based on the scalar physics of in this instance here. I would say that what I'm looking at is Tom Minderle's paper. There's a brief introduction to scalar physics. I really also what was his name? Like Henry Lindner. Oh gosh, let's see. Yep, Henry Lindner. I saw that just a few weeks ago, and I thought that is what I needed. It's the fluidic model of flow, where the universe is actually in constant motion as a fluid, and gravity is the acceleration of that fluid movement into the center of mass of a massive body, or in Haramein's take, it's into the center of a proton. And there is a stability there that forms that we are part of that substrate, just in terms of a resonant vibrational state, which is all baryonic matter is, right? So if we are constantly moving with it through the universe, perhaps in a toroidal form around a central black hole of the universe that is just periodic, we would actually be bound intrinsically to this medium, to this substrate. If it's accelerating into the center of mass of the planet, then we are being we're linked to it because we're part of it. We're being pulled into the center as well, but gravity is the resistance because we can't get past the surface of the massive body. So that is where I'm thinking gravity lies. And to me, that is really simple. I can cope with that. I don't need the general relativity. I've looked at it, better looked at it. The paradoxes are there. It's overcomplicated, and this theory, this fluidic theory, just makes perfect sense to me. Anyway, my opinion, always up for debate, but that's the simplest way I could do it, and I need simple things because you're only as good as the concept. So anyway, so here I've got it switched on, and that is the window, which is based across, it's coming up there. It's about 200 hertz, basically. It's what I've got it running at. Let's put it on the leg of one of these. These are MOSFET drivers to drive the little, those are little transformers to basically separate the low voltage side from the high voltage side, which is there once the high voltage DC comes in. So you can see them here. That's the burst gate of the system. Oops, let me just do this, and I'll just capture it. No, not there. There it is. Okay, so if I show you that has a set period, a gated period, to match the end of the resonant frequency, so that you don't have to do that, but it just seemed to make sense. But when you go into it, you see that I've got quite a nice square wave of the resonant frequency going through all the logics here. I specifically did it that way. And so basically that's what's inside each of the bursts, and that's, what is it? Let's see, do I have it here? Yeah, there it is, yeah. Okay. 1.092 megahertz. And that's what you can see spiking here. The screen's not working well, but it's spiking up nicely there. There are a few sidebands around it as well, which I think I should expect because of the pulse windowing that's going on as well. But yeah, so that's how that's working. This is a piezo. It's a 1 megahertz barium titanate piezo transducer that's inside the shell in the cavity, and that is what is showing up here, and that's the frequency there. Oh, that's not right, but anyway, it's a really messy signal, which means it's really low Q in there and the whole system. So I'm changing it to make it work, but that's not the main problem. I mean, the frequency is there. Oh dear. Well, it looks like it was there. It has looked better than that before. I don't know why it's so bad, but anyway, but the problem is that as soon as I turn on these, this was not a good moment. It does that. And what that is, when you zoom out, that is a really beautiful frequency. That is, it says it's actually about 70 kilohertz, which is actually the switching rate of these high voltage bricks. They were really expensive, supposed to be super quiet, and they destroyed all of my frequencies inside here. So I couldn't finish the experiment because they ruined it. by their noise, basically. So I mean, I'm just running about 500 volts aside. These are buck boosts, so that I can fine adjust each the positive and the negative feed into the spheres. So, but yeah, I mean, as I say, there's 6,000 volts each. But there's a lot of resistance that I have to use mega ohms in there for specific things and returns to actually get things to behave right. But anyway, it's yeah. I've had a complete rethink. I'm going to use this bipolar Tesla coil, which I've wound, and it has two rods, one for each polarity, one for each side of the coil. It's like a coil that's mirrored, but it's series joined in the center, and reference, that's like the CT, the center tap. So next I have to do is try to see if I can find a family of resonant frequencies within this to work with this. And also then I'm going to reintroduce the FGM, as I call it. It's the field gradient modulator, and this will sit over these coils. And again, this is it's in a 4:3 ratio to the 3:2 ratio to that, which makes this an octave higher than the inner sphere. And but what I did with this was to wind it so that it has a knot turn. So basically it's self-canceling. It's canceling the B field on one turn. The next turn, it's both turns in the same direction. So it's a B field is not cancelled. The next one it is. The next one it isn't. So there are 15 layers, which means that there's an imbalance between I've started here and it stops on the one before down here. So there is an asymmetry in this coil. So these will be fed either end of the Tesla bipolar, and the rods will be fed into this on the outside, because that is the displacement current and that's what moves it. I needed a magnetic field to create the toroidal form to actually capture the AC capacitor that it is now in the middle and transfer that. And then the bursting, I'm still going to burst it, but not in this way. I'm just going to rebuild some logics there so that it does a different thing. But I'll do another video on that later though. But basically that's what's next on the plan. So I haven't been idle. I'm working hard actually at this, so, but it's fun. The word on AI, it's been incredibly consistent of late. It was horribly inconsistent about 5 months ago. I was building circuits, nothing was working. Suddenly something changed when 5 came out, GPT-5, and it was consistent all the time. You have to keep, I mean, it's the same thing though. It's garbage in, garbage out. That's the bottom line. If you feed it nonsense, it'll give you nonsense back. And you've got to watch your own confirmation bias in terms of what you're trying to achieve. But there are ways through it that make the whole thing a very positive experience. And I couldn't have built this without it, because it is a lab assistant. It's like a professor in the lab at the same time, because it's advising you how to do stuff. So you have the ideas and it enables you to do this. So it's wonderful. So, and it's, yeah. And it knows how to program these. There are pages of code. I started with an Arduino Nano, and I had to upgrade it to a Nano Every because I ran out of memory on the Nano, because it had such a small little EEPROM or RAM or whatever they have in them, for the amount of code that it was pumping out to do all the switching and the code for, you know, even the encoder, the OLED on top. I had to leave them off because there wasn't enough room for the code to run these. And so anyway, but it's, yeah, it's having fun. Anyway, thanks for your patience. Thanks for listening. I'll put this up here just so you can get an idea of what I was talking about earlier. All right. Thank you. Okay, I don't think I even explained what it's really for. So that might give you a clue. I should say hover in the middle, because that's what success would look like in this project for me. Anyway, so the whole thing is completely autonomous. It's battery powered. I've got a 3 amp hour LiFePro 4 battery in there, on off switch outside, and the battery lasts for days, even during testing, which is great. And yeah, so the idea is, I mean, it's all just about field manipulation. You know, if I can get an axial movement, a net vector upwards of the substrate flow, and if gravity is the substrate flow going that way towards, and it's the acceleration of that, not just the movement, it's the acceleration of that that forms us stuck to the planet. If I can actually get it to go the other way, it's kind of like a fish in a very strong current. They find turbulent lanes that allow them to basically just sit there and almost effortlessly just sit there static in a very strong current. It's exactly the same thing. It's all fluid dynamics. At least that's the way I see it today. So it's a question of moving the substrate, and the key, I think, is that the displacement current moves. It actually actively moves it and affects it. The A field and the B field. A field is kind of more like the current in an ocean, right? It's a generalized movement, but the displacement current is what really affects the substrate and gets you like immediate kind of movement, because it's the only current that exists in a dielectric. And it's exactly the same, I think, as the rod energy current is a displacement current coming out of the center of the Tesla coil. It has, and I think that is in itself, displacement current is moving substrate. Simple as that. So direct it where you want it to go, amplify it, create a vortex, and that's what this is for, because the vortex, this has nodes to give it chirality, to give it spin as part of the electric field and part of the scalar field that it forms, so that the whole thing can actually move in a coherent fashion. And that's the whole thing. Coherency requires very little input energy to make things happen at a grander scale. That's what I feel. Anyway, thanks for listening.